Okay, so let's see how the file allocation table works and how it can take a file that we want to save, divide it into cluster in the secondary storage, like in the disk, and using the file allocation table, tell you what is which clusters, those are clusters, which clusters are used in what order and to which extent are used to save your file. So there is directory entry. The user wants to save a file, then it's go to the operating system and we have a file, its size and starting cluster. You'll see that we have a file here, and then we'll go to the data area, to the clusters, secondary memory like the disk, save the file using like clusters. So if a file needs, for example, 4 clusters, so we take, for example, this area, and then the file location table will tell me where is the file. So let's see, we want to write this file, and we start with cluster 2. So the file location table tells you for each one of them what is the next cluster to go to. Because either 2 to 3, so from 2 to 3, from 3 to 4, from 4 to 5, and from 5 to 6. And then it tells you 6 is the end of the clusters, namely take all those clusters together, they form um, your file, and we can read it that way. Now it doesn't have to be that contiguous. It may be that 2, and then we get to cluster in 11, and then it will write here 2 to 11, from 11 to 18, so it will be here 11, so it will be 11, and then it will go to 13. It doesn't have to be contiguous. Another way to see this is like this. We can create a file name. Let's go C with 6 clusters. So let's see how it works. So let's create it. You can see that I create those 6 clusters, and the file location table does tell me from 0 to 1, from 1 to 2, and I can read this. And how do I know how to read it? I go to here, and then this one, and then that one, until I get to the end of chain, and then I know that I finished reading the file. Okay, so that's it. This is some words about the file location table, and that's it.